Welcome back to the another session of our data structure. So today we are going to complete the implementation of Stack using C language by help of the linked list. Last video we are already cover how to implement by using array. So today we are going to cover how to implement by using the linked list. So before going to details, we have to just understand what are the drawbacks. Why we have to go to the linked list. For example, in case of array implementation, this is our stack. Stack consists of number of element where insertion is done from one end, where we call as the push operation. Deletion is also going from one. From the same end is we called as the pop operation. This is our top. So when we implement it, that time we represent the stack or list of element as a array, and we are making the indexing. So the maximum size of array, for example, I declare the 5 or 10. After that, we cannot able to insert the element. That's why the situation occurs we called as the overflow. So the condition we called as the overflow condition. It means that we want to insert the data. There is no space inside the stack and we cannot able to insert due to array implementation because array is static. Once we declare the size, we cannot able to insert the element. But if we go to implement the same concept by help of the linked list, then what happened? We can able to allocate the memory as per our requirement. So there is no situation for the overflow. There is a situation for underflow. Means if there is no element, we can go for the underflow condition, but there is no chances of overflow. Space is there. We can go for the dynamic memory allocation and we can able to implement it. So this is the main advantage of using the linked list representation for the stack. So next question, how to do it? There are two operations, push and pop. Push and pop operation. So linked list means, for example, here we store the 10, 20, 30, 40. So if we are go for link array representation, what we are going to do? We are make the linked list array representation. So this is 0, 1, 2, 3, 4. So 0 means this is 10, this is 20, this is 30, this is 40, this is 50. So on we are making, so we make the indexing is this one. So from this position, we call as the top. Here we are making the push operation. Here also we are making the pop operation. Means from one end we are going to do. This is the way we are just performing, means we representing in array. From one end we are inserting. From that end also we are removing. So this is called as the top of the stack. And initialization is the top is this position, that is the -1. So this is the condition for the underflow, means there is no element. So here we declare the top equal to initialization -1, means there is no element in present inside the array. All the details I covered in my previous video. I also put in description section the link. You can go to the link and just understand. If you understand the array representation, whenever we move to the linked list representation, it is easy. Next, our main topic is how to do it. So linked list means number of nodes are connected each other. Connected each other. And there are two pointer. We are already covered start pointer as well as the last pointer. Simple. So whenever we can insert from any position, we can insert from first position, we can insert from the last position, or in between we can insert. So this is case of linked list. But what is our objective? Our objective, insertion and deletion should be done from the first, only one end, and that end we called as the stack. So for example, this position we want to insert. And from this position, we want to delete the link. So whenever a new node is new data we want to insert, so what we have to do? We have to simple create the node, make the link connection and make the start pointer here. So whenever we want to delete, we can remove the element. So this is the way we can able to do it. So this is a very simple example how to perform the push operation or pop operation. So in this case, we don't require two pointer because insertion and deletion both are we are going to perform only from one end, this end. From this end we are going to do. So there is no need for the last pointer, only we require start pointer. Start pointer, as we know, the topmost element always we point it, we need a pointer which points to the topmost pointer. So this pointer we can make the name as a top, instead of start we can make as a top. So here we make this pointer as the name as a top. So now I make this pointer top name as a top. For example, I have to push an item. So how to do it? Push item means inserting an element from this side. So we have to create a node, store the data. Now this value, we cannot directly make a connection here. If we make a connection, then what happened? All the information we lost. So that's why we have to create another temporary pointer that point to this node. Then what we have to make? We have to make this node as a first node. Then we have to make the connection to it. Then what happened right now? Top remove connection is gone now. This is the top element. This can be possible. This is the way we can able to do. So whenever there is no element is present, so at that time, what is the condition we have to write down? We have to write down top equal to null, because there, if there is no element means we can make the top equal to null. For example, we want to go for pop operation. Pop operation means we have to remove an event. So what we have to do here? This is the, for example, linked list is present. Now we have to go for to delete the element. Deletion means we have to make the connection to this one. If you make connection direct here, then what happens? Which element is deleted? We may not able to know. For that, we have to make another pointer that is point to the first node. So this is our first node. So first element, for example, this is 10, 20, 30, 40 is present. Now it's point to the first node and is the topmost element. So then we can go for that top is equal to top next. So now what happened? If we make the top is equal to top next, then what happened? Now top point to point this one. Now top is, after that we can remove the element, or we can remove the element means by we can write down percentage this element is going to be deleted. Then we release the memory of temp. This is the deletion. Means we free by help of the function, that is the free, we delete this one. So now you tell me, whenever we go for push operation, what operation we are performing? We are performing insert an element into begin of linked list. This is the same. Whenever we go for pop operation, it is delete an element from begin of linked list. So if we understand these two concepts, means how to insert an element into the first position of the linked list, how to delete an element first position of the linked list, then our push and pop operation of the stack is over or not. So over, there is no condition for the stack overflow, only underflow is present. What is the underflow condition? When the top is equal to null, the stack is underflow. So this is the concept we have to understand, how to perform push and pop operation by help of these algorithms. I have already explained in my previous video, and in description section also I put the link so that you can understand all the concept thoroughly, so that it is easy whenever we are going to implement the program. The same program last video we covered by using the array, the same program, little bit modification we have to do for the linked list representation. Program to implement the stack by using array. My last video we are already covered the program. So this program we are just going to modify. Main reason is that the main function, the same thing we are going to do. So I don't want to waste our time for writing the main program. That is the main objective. I just modify with our existing previous program. This program details we are already completed in our last video. So here linked list, implementation of linked list we have to change. Push, pop, exit, all the things. The same function also we are going to use here. So no need to do any changes. So what are the things we have to do right now? So main function only we have to change the implementation of stack using linked list right now. This is the stack implementation using linked list. Here we are doing the program for the linked list representation. So we don't require max size also we don't require. Maybe yes, we require choice as well as a top we don't require because we are going for the pointer. So stack also we don't require. So these are the things we require. Next one. So before going to the details here, we have to first declare the structure. So first we have to define our structure. So here I use the type def. Reason is that I don't want to write down each and every time the structure. That's why I define the type def. Previously, we use only structure node. In this program, I just introduce the type def. Reason is that each and every time we don't have to write down the structure node. If I write down node means automatically it will be reflects that it is a structure. Integer info, for example, the data we want to store in the variable info, then node star next. Previous what happened? We have to write down the structure node. Right now we don't require to write down the structure node because I have already done the type def. So next, what are the pointers we require? Minimum pointer we require one pointer to store the top value. So I have to write down node star top and we have to initialize the value equal to null. Then another pointer we may require for the creating a new memory store the address of newly created memory. For that I just use the current pointer. During any operation we may want to store the uh, top value. So for that also I declare another pointer temp. So these are the pointer. We only initialize the top pointer equal to null. This is the case when there is no element present inside the stack. So this is our declaration part is over. Here what happened? No isempty is present, isempty function is present. So we have to think what is the condition for isempty. If top equal to minus 1, no, if top equal to, in our case, null pointer, it returns 1, otherwise returns 0. Means if whenever top value equal to null, means there is no element. So this is the case of is empty. At that time, stack is empty, otherwise stack is full. So whenever stack is full, it is not full, the element is there, then at that time it will returns the 0. So next function is full, we don't require because there is no chances of overflow because we are go for the dynamic. Next function, that is pick function. So for pick function, what are the changes we require to do it? Pick means the pick function is used to retrieve the topmost element present inside the linked list representation of stack. So first we have to check whether whether the stack is empty or not, whether any element present inside the stack is empty means print stack is empty underflow. Otherwise we have to retrieve the topmost element. In case of array implementation it is stack top, but here what happened, we have to use the top info because information part store the data value. So here we have to use the info. So this is for the pick function. Only little bit changes we have to do. All the details of the complete program are already present in my previous video. If you want, you can go to that video. I have already mentioned in my description section. Next function is push. Push means each full. No, there is no chances of each full. So each full we don't require. Only one thing we require whenever we go for memory allocation, whether memory allocate or not. This is the possibility. So here we have to write down current pointer means we are already declared no type of pointer. Here first we have to allocate the memory. Whenever we go for push operation means we want to insert a value. So at that time we require a malloc function to allocate the memory. So malloc size of how much memory required we don't know. So that's why we have to write down node. So it allocate the memory. Once the memory allocation is done, at that time we have to check whether memory allocation is done or not. So for that, if current equal to null means memory allocation is not done. At that time we have to print printf this is the case we are mentioning, but by very less chance. But anyhow, we have to take precautions. So if current equal to null, memory allocation is not possible and push upon else means memory allocation is done. So whenever memory allocation is done, at that time we have to check whether the element we are inserting is the first element into the stack or not. If it is first element means that top equal to null. So here top equal to null. If the top equal to null, then what we have to do? We have to make the current node equal to, sorry, top equal to current node. Then, then top next store which value? Next store value of null. One more thing, whenever we are storing the value, memory allocation is done means anyhow we have to store either first node or any node. So at that time it is compulsory that we can store the information part in both cases. So this we can make the current info store the value, whatever value we want to store. So this value we have to store. So next question, what is the value of n? So we have to read the value. So printf enter the so we have to enter the element to the stack. Once we enter, we have to scanf. Once we scan, we store in the information part. Then we have to check which location we have to insert. If top equal to null means now make the top value equal to current node and top next we have to make the null. So this is for first element into stack. So this is the case for first element into stack. Otherwise, else otherwise what we have to do? We have to store the first top value. Top value we have to store inside the 10, then top equal to current node, then top next store the value of temp. Temp value means remaining part of the element present inside the stack. So this is the three step. Temp equal to top means top pointer right now store inside the temporary value. Now the top we make the current node. So current node next right now the remaining element present inside the linked list. So this is the operation we have to perform for the push then pop. So pop means removing an element. So removing an element means we first this we have to check whether empty is stack is empty or not. If the stack is empty means we cannot able to remove any value. Else means element is present. So what are the things we have to do? Anyhow, this program we don't require. So we want to print the value. So before printing the value, what happened? We have to store the value in a temporary pointer. So we make the temp equal to top. Once we store the value, then we make the top equal to top next, means next it will go to the same as the top minus minus in case of array implementation. We are point to the next node. Then we have to print the value. Percent is the pop element. So here what happened? Top, not top. Right now it is temp. Temp info, store the info value. Once we print the value, then we have to release the memory. So free temp. So this is the pop function. Means how to remove an element from the first node of a linked list. Then we have to go to display. Display means same thing. We have to check whether any element present inside the stack or not. If the element is present, then only we can able to delete. Otherwise, we cannot able to delete. So else means element is present. So traversing all the element, first we have to write down temp equal to top. Then while temp is not equal to null, this is the end of the stack. Here we have to printf. Then what information we want to find? Temp info. Because we store inside the temp info. Then temp equal to so this is all about our function. This is the main. Let's compile the program. If any error, we have to rectify it. Okay, so sorry. Okay. Here we have to write down the struct keyword. Then only. So this is size of current malloc size of node. Malloc was not declared. Okay. It means that we are not declared here. So the malloc function is present inside which other file? stdlib. Again we have to compile. Now no error. Let us compile and run. So 1 means we have to enter the value 1. Then again we want value 2. So we enter 3 element 1, 1, 2, 2, 3. Right now we want to display. Yes, it is first element 11, then second element, then third element. Okay. Now I want to pick 3. 33 is the topmost element. Yes, it is topmost element. Then I have to go for pop. 33 is pop. Then I have to again go for pop. 22. Stack is empty, underflow. So here we cannot able to retrieve the data because our stack is empty. There is no element. So we perform all the operation here by using linked list of stack implementation. Hope you are able to understand the concept. So whenever writing the any program, there is a chances of error. Don't worry. At that time, when you are facing any error, you just try to rectify the error. Then only it is easy. Data structure program is very easy, but you have to start from small program and you have to add on the concept and go ahead. This is our complete program. Yes. We are already completed and we are already executed and rectify our error, all the things we have done. So thanks for watching my video. Hope you are able to understand the concept of Start by help of the linked list in C language.